So let's take a few minutes to build our intuition on some of these rules of probability. Why are we multiplying or adding? Where do these come from? Well, you've gone through and learned about these different rules. For example, the multiplication rule, the addition rule, and maybe even the conditional probability rule, or when something is given to us. But these formulas, they kind of just look like symbols and letters, and where do they actually come from? Let's get a little bit of intuition about this. So first, let's understand the idea of taking a percentage. So whenever we multiply to find a percentage of something, if you think about it, we're really just taking a piece of a whole. For example, if I have a pie here with 8 slices, and I asked you to take 25% of that, well, if we did 8 times 0.25, or 25%, by multiplying, what we find is we get 2. So that multiplication process gives us that 25% is 2. It's that piece that represents 25%. So whenever we're multiplying, it helps us take a piece of a whole. Well, the same thing happens when we're working with AND probabilities. So if you think about the AND probability by looking at a Venn diagram possibly, we have one event where one thing is happening, and then we have another one, and remember the AND represents the overlap. How much is in this overlap? And that's what we're looking for. The AND is where both of them occur. And when I overlap this, we see we're really just taking a piece, this section right here, of the original first circle. We're taking a piece of a piece. And that is our multiplication. Let's take a look at this with a more concrete setting. So imagine we have 40 people in a room. And let's say one of the events we're interested in is just choosing someone with glasses. To be in the Cool Kids Club, you have to have glasses. Well, out of these 40 people, we see that there are 12 of them with glasses. Well, what if I wanted to see the people that have glasses and also have a watch? Well, there's some people over here that have a watch. There's also some people on the right that have a watch. So we see that all of those people put together have watches, but if we're looking for the people that have glasses and a watch, we're really only looking at this section on the left. These are the people that have both. So notice what we're doing here is we started off with a big group. We're taking a piece of that big group, which is the people with the glasses. And now we want a piece of that piece to have both glasses and watches. The piece that we're going to take of that is just this section over here. So we don't want to ignore the ones on the right. It's only this piece here. And this is our AND. So notice we took a piece and then we took another piece. So we're multiplying to take a piece of something. So looking at this in terms of probability, what if we said, again, with 40 people in the room, what is the probability of selecting a person who has glasses? Well, from the picture, we see that there were 6 people left out of the 40 that have glasses and a watch. And if we did that 6 out of 40, well, that would be a 15%. So there's a 15% probability of choosing someone that has both glasses and a watch. So notice we did not have to do any multiplication to do that. Multiplication is a tool that can help us sometimes. And you don't always have to use the multiplication rule whenever we see the word AND. However, let's approach this from the AND type of problem so you can see how the multiplication rule is actually working in this case. So imagine we wanted to find people who have glasses and a watch. Well, one thing we know is that the probability of glasses, well, how many people are there? There are 12 out of the 40. Well, if we took 12 out of 40, that's 30% of the people in this room have glasses. And then we also could count that out of all the people with the watches, there were 14 of them, 14 out of 40 that have a watch. That's 35%. However, we're not interested in all 14 of them. We're only interested in the people that have a watch given that they have glasses. So it's only out of those that have glasses. So if we look back at that picture, again, we're not interested in all of these people that have the watch. We only care about these 6 here on the left. Those are the only ones we care about. But it's out of all 12 of the people with glasses. So when we're looking at that, 6 out of the people with glasses, so out of the 12, would be 50%. So the multiplication rule tells us if we want the probability of glasses and a watch, we need to multiply the probability of having someone with glasses times the probability of someone having a watch, but only out of those people that have glasses. That is the multiplication rule. And when we do that, we take a piece, so we take that 30%, and out of that 30%, we're taking another piece. We're taking half of those 30%. And we see we get the exact same answer, 15% that we get for both from the multiplication rule and from actually using just the picture and looking at it. So let's think about the addition rule now. What if we were just interested in people who have either glasses or a watch? So if you have one or the other, or maybe you have both, then you can belong in this cool kids club. So again, we have the 12 people with the glasses, or we have the 14 people with a watch. So all of these people that are marked are people that can be in this club. And let's count how many people there are total. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Plus we have over here 13, 14, 15, 16, 17, 18, 19, 20. So 20 people total can belong in this club. And so if we were to look at this, we would have probability of selecting a person who has glasses or a watch. Well, we counted that there were 20 people that had either glasses or a watch, or maybe both, and that would be 50%. But how would this work using the addition rule? Well, going back to our picture here, maybe a faster way of seeing how many people there are total would be to just add the groups together. We started off with 12 people with glasses, and then we're adding these people over here to the group, which there are 8 more. And so if we added 12 plus 8, that could give us the 20. Now, that's not usually what we think about, though. We might think, oh, how many people have glasses? There are 12 that have glasses. If we count all the people with watches, there are 14 people with watches. But one thing we have to watch out for is if we do 12 plus 14, that's going to give us too many. 12 plus 14 would be 26. And why do we have too many? Well, that's because of these 6 people here. They were in both groups. So when I added the 12 plus the 14, these 6 got counted twice. I don't want them counted twice. I only want them counted once. So why don't we just make sure they're only counted once by subtracting them out? If you notice, if we take all of them again, we have 12 plus 14 with watches. That's 26 minus these 6. That brings us back to 20 people total. And that's exactly what the multiplication or the addition rule is doing. So let's take a look at the addition rule. The percentage of people with glasses would be 12 out of 40. The percentage of people with a watch is the 14 out of 40, or 35%. But remember, out of those two groups, there were 6 of them out of the 40 that were counted twice because they have both glasses and a watch. So if we just use the addition rule, then this is saying that, okay, we could add those two groups together, the glasses and the watch, but the people that were counted twice, we subtract them out, so they're only left with it once. And so we get 0.3 plus 0.35 minus 0.15 is 50%, which is exactly the same thing that we got just visually counting them versus using the rule. So once again, we see the addition rule is a tool that can help us get to that probability. It's not necessary to use it all the time, but it is very useful when we have less information and we can't just count it. So we see, again, let's just look at those intuition type of thinking on why we use multiplication and why we use addition. Whenever we're talking about multiplication rule, which is the and, remember that our intuition is we're finding the overlap whenever we're talking about the and that's taking a piece of something. And as we've learned, multiplying by a percentage is like taking a piece. So by multiplying and multiplying, we're taking a piece of a piece. The addition rule is we're combining groups. So when we're combining them together, we're just adding them up. That's our intuition for the addition rule. Is if I want 2 groups and I want to see if you're in one or the other, we can just add them together to make one big group. However, the thing that we have to watch out for is sometimes there are people in both groups and we need to subtract them out to avoid counting them twice. And lastly, you might have seen this part a little bit, is the conditional probability. We saw this when looking at the multiplication rule. So the key thing here is whenever we see this given bar, that's right here, then we can always interpret that as like out of, meaning we're trying to find what's the probability of A, but only out of those that are also in B. And so what does that tell us? Since it's out of B, then B always goes in the denominator. And you could see that in our calculation from the end right here. If we wanted a probability of watch given they have glasses, it's out of only the people that had glasses, which are the 12 people. And what did we want out of those 12? Were the 6 that also had a watch. Not everyone, but only those out of the glasses. We can ignore everyone else. So those are the 3 rules. Hopefully this little video has given you a little bit more intuition on when we multiply, when we add, and why do we do those, or when do we change the denominator.